Hey guys, welcome back to section 2.3 with biconditionals and definitions. Just bear with me, I'm trying to get my voice back, so hopefully this isn't too nasally and weird sounding. A biconditional statement let's break it down. Bi means two, so basically we have two conditional statements. So we learned about conditional statements before where we talked about P and then Q, and we talked about our converse, which is Q then P. Our biconditional takes those two and puts them together, and you see here it's got the double arrow, so it's going P to Q, and it also does the converse of Q to P. So an example of this is a midpoint if and only if it divides a segment into two congruent segments. Now notice here it has that if and only if. That's what makes a biconditional statement. It does not use the words if and then, it uses if and only if in the middle. Again, our symbol is a double arrow to let us know it goes forwards and it goes backwards, and we read it as P if and only if Q. Now, if and only if is sometimes written shorthand as IFF. So you can write it that way as well. You don't have to write out if and only if. So let's look at this and figure out what is the converse of the following true conditional statement. If the converse is also true, rewrite the statement as a biconditional. So here's our statement. If the sum of the measures of two angles is 180 degrees, then the two angles are supplementary. So let's identify our P and our Q. So our P is the sum of the measures of two angles is 180. Our Q is the two angles are supplementary. So our converse switches those. If two angles are supplementary, then the sum of their measures is 180 degrees. So this converse is true. So you can form a true biconditional statement joining the true conditional and the true converse using if and only if. So our P is the sum of the measures of two angles is 180. Our Q is, again, our angles are supplementary, so we're going to join those with our if and only if. Two angles are supplementary. If and only if the sum of the measures of the two angles is 180 degrees. What are the two conditional statements that form this biconditional? So a ray is an angle bisector if and only if it divides an angle into two congruent angles. So here's our if and only if, which makes this our P. Our ray is an angle bisector. Our Q, it divides an angle into two congruent angles. So we've got our P, we've got our Q. Again, P is a ray is an angle bisector. Q is a ray that divides an angle into two congruent angles. So one conditional would be P to Q. If a ray is an angle bisector, then it divides an angle into two congruent angles. Our other conditional statement is going to go Q to P. If a ray divides an angle into two congruent angles, then it is an angle bisector. Now let's talk about definitions. Definitions can be written as biconditional statements. And is this definition of a quadrilateral reversible? So that means, can it be written as a conditional and can it be written as a converse? If both of those are true, then yes, it can be a true biconditional. So here's our definition. A quadrilateral is a polygon with four sides. So let's break this down and talk about what makes a good definition, what makes it reversible. So write the definition as a conditional and the converse. If both are true, then this is reversible. So let's break this down. My conditional is if a figure is a quadrilateral, then it is a polygon with four sides. Well, that's true. So let's check my converse. If a figure is a polygon with four sides, then it is a quadrilateral. Well, yeah, that's true as well. So I can make a biconditional. A figure is a quadrilateral if and only if it is a polygon with four sides. Next up, let's talk about what makes a good definition. We've got four options here. A fish is an animal that swims. B, rectangles have four corners. Or C, giraffes are animals with very long necks. Or D, a penny is a coin worth 1 cent. Alright, well, Yeah, a fish swims, rectangles have four corners, giraffes have long necks, and a penny is worth 1 cent. But only if one of these is really a good definition. So, some things that make good definitions. They need to be reversible. So they need a conditional and they need a converse. The definition uses clearly defined terms, so nothing that's vague. Everything has to be exact. And again, it has to be exact. Your definition is precise. So let's look at A. A fish is an animal that swims. Well, A is not reversible because you have the counterexample of a whale. A whale swims, but it's not a fish. So A is not a good definition. If we choose B, corners doesn't really tell me anything. What's a corner? I mean, rectangles have four corners. Okay, but what's a corner? So, and other things have four corners. A square, a rhombus. So, not really a good definition for a rectangle. In question C, or choice C, very long neck it's not a surprise. I mean, how long is very long? And also, ostriches have very long necks, so that's not really a good definition for a giraffe. So, last one is D. D is our best option. This is reversible. If it's a penny, then it's worth 1 cent. Or reverse that with a converse. If a coin is worth 1 cent, then it's a penny. That works. All the terms in this definition are clearly defined. Yep, so it's very clear. You've got a penny, and it's 1 cent, and it's a coin. All the terms in this definition are precise, so there's nothing vague about this. You're not saying a penny is not worth much. You're saying exactly what it's worth. So this is a really good definition. All right, that's it for now. Toodles.